Welcome to our basic tutorial of Quick Surface. In this tutorial we'll just go through and find out how to make reverse engineering of this turbine with its blades in a couple of steps. And from this mesh, how to reconstruct this result. So let's get started. We'll just open my STO mesh and put it in Quick Surface. I know that it's in millimeters and I'll leave these as they are. So I see the STL mesh on my screen, and the first thing I want to explore is how it is oriented in space. For this reason, I'll just enable the coordinate system and see how it is aligned. I'll put it on top view and I see that it is okay. You can watch our other tutorials how you can align your scan data, but for now I don't need this and I can start to do the reverse engineering. So if I look at this, I see that there is a main body which I need to reconstruct, and then I need to make the plates. Furthermore, all I need to do is probably reconstruct only one blade, then use the pattern and put it around. My goal will be to create solids because the software works well if you combine the solids. So for this reason, I will start with my main body. I will put this in the top view and I will go to the mesh selection to actually identify and tell the software which area of the mesh is my area of interest. I will use the magic wand and I start clicking on the screen just to get this area which are of my interest. So using the magic wand and with the slider you can adjust the sensitivity so you can get the surfaces that will be good for your area. I will turn off the coordinate system because I don't need it. Probably here if I don't get anything I will miss information, so I will just use the slider to get more information. I can also use my brush. In this case I will make sure that the select rule is not turned on so I can paint a bit more to get more information. My goal is just to mark in red what I need for now. Also, as I see that this is not exactly a cylinder, so this is for me a revolved surface, which means that we need to define the profile and then just create a simple revolve. For this reason, I will go and start creating a 2D sketch. The 2D sketch by default is defined for the extruded surfaces, which means you can move it up and down. But in my case, what I need is actually to create a sketch that will be revolved. I will just select for the revolved surface, and by default it takes the z-axis, which will be used. So all I need to do is just identify my profile. This is why I created my selection, because in this case the section will go only through the selected points. I can always turn this on and off, and you see that now the profile actually takes some points from the blades, which is not what I need. So I'll use the selection option here. Also, it's good to know that when you do reverse engineering, it's always good to have more data so your information is more representative when you reconstruct, especially the revolved surfaces. For this reason, we have an option which is called stacked section. What it will do, it will just take the 360 degrees divided by 20 in this case. We'll create all the sections and put everything into this sketch. So I'm okay now, and I'll press create to create my sketch. What I see on the screen is extracted information from my mesh, and here I can actually start creating my primitives. I can draw lines on the screen, but we have something which is called selection option, which means that I can paint over the points and just tell the software to define what I need, like a line, arc, or circle. In this example, my instant fit is turned off, so I can just mark areas which will define my line here. And as you see, the software automatically gives me a suggestion what this is, and I can choose and tell that this is a line, for example. We can use the instant fit, which means that if I select a fit line, this means that when I just finish my painting, it automatically will generate my primitive. So this is quite an easy tool quickly to just extract my primitives here. I paint here and I extract my lines that will define my body. My goal here is to create a solid, closed sketch that can be revolved. When I'm ready, roughly I can go back and start adjusting my sketch. When I mean adjusting, I need to tell the software that this is a vertical, this is also a vertical line, this is a horizontal, and this is because the design intent, although we made this fit line to go the best through these points, we know that this is actually a horizontal line, and I can tweak here and adjust the position if I want to. Also, I can define the other lines too. So now this is not enough. I need to close to connect these lines here. And for this reason, we have something which is called corner trim. You can just paint over the corners and the software automatically will join your endpoints. I'll go back and show you something a little bit different. If I hold Control, I can do the same, so you don't need to go to this mode. You can always just paint with the Control and you see that it connects. I don't see any orange points now, so this means that the sketch is closed. Furthermore, you can add here, for example, dimensions. I can take these two lines and define my radius. This is what we need to be as an inner cylinder. Also, you can define a thickness here, which you can adjust and put the numeric values. I'll leave them here for now, and you can actually put the different values if you want to. When I'm ready, I can just press OK. What I see on the screen is my sketch, and I need to actually revolve this sketch to create a solid. I just click on the sketch. The software automatically shows me an icon what I want to do, and of course in this case I want to create a revolve. So I created my first step, I created my body. I see that here it says it's a solid body, which means that everything is going well. But the question now is how good am I with respect to the scan data? I will just unselect all the points because I don't need them to be selected anymore. And at any point during your work, you can always press compare to see your results. In this case, I'm working with 50 microns accuracy, and I see that my body is quite well. Here, we identify that there are some issues with the object itself, but again, now it's the moment to think what is your design intent and what is the actual radius of this cylinder, and you can discuss with your customer how and what these values should be. For example, when I have my revolve surface, I can right click and edit the sketch itself, and for example I can round this number for something that is machinable, for example 13.8, and then I press OK. As you see now, everything is re-updated and I have my new body. I can compare again to see if I'm too far out of the tolerance, but everything looks okay so far. So I'll put this in top view and we are ready to move to the next step. We can move on to the next step to recreate the blade. Again, what I will do now, I'll just take one single blade, we'll create it, and then I'll just use a pattern and we'll just create multiple instances here. I will hide this surface for now because I don't need it, and I put it in top view. I will go again in mesh selection, and this time I will use the paint selection, and also I will make sure that now the select through is on. I will just select roughly the area which is the blade that I'm interested to work on, and I will click on the isolate. This means that it will remain on the screen because it's easier for me to work on. As you can see here, I have something extra that I don't need it. In this case, I will just hide the selected triangles. And probably I will hide this also because I don't need it. Now I have my blade and I can start work on it. What I see here is actually the loft surface, and I can easily recreate this by creating two profiles at the bottom and at the top, and then I can just create a loft. But this is a free form in space, so if I put it on top view, there is no way for me to make this section here. So the easiest way to do this is to use the 3D sketch, which is located in the surfacing menu. Clicking on surfacing, I select the 3D sketch. What I can do now, I can just draw my lines and try to create my profile at the bottom, and then I'll create another one on top. I will just start just clicking and creating my profile here. Now it's always good to keep the minimum number of points here so you don't get too wobbly splines, and I just roughly and nicely recreate where my profile will be. It is good to know that what we have here is what is called tolerance display. When you turn this on, and in this case it's set to 30 microns, you can see a color map of how your curve is in respect to the reference mesh. And I see that this is good, so you can play more, you can insert more points, and you can make this better. But the question is how I can round this here. And for this reason, we have something which is called a blend curve. It's quite easy. You pick one end of the curve and then you click on the other end, and it automatically will create your blend curve. As you can see here, we get immediately a color deviation of how close we are. Just to see, this is my shape here. So probably we need to tweak this, and I can just use the handles and we will adjust this until it gets closer to my tolerance. I can play with the two handles, and you see that this is now okay. I will do the same on the other side. We'll use the blend curve. Click on the first point, the second point, and I got my blend curve. This is blue, which means that it's inside, so I can probably use my handles to adjust the blend curve here. And you see how easy it is to get into the tolerance which you want to have. I will do the same for the top. I will turn this off for now, and we'll just draw my top curve here with the 4 points. And then I'll go on the other side and create my other curve, which is here. As you can see, this through, so be careful that you don't pick the point on the other side. I will just click here and here. So this is my other guiding curve. Again, here I need to create my blending. Let's do it in the same way. Select the blend curve, pick the 2 points, and then we can adjust these. You can play yourself and adjust these points in the right position. You can use the tolerance display to see how close you are with the reference mesh. This is good for me. I will move on the other side. Again, we'll select the blend curve, click the 2 points, and adjust the blending. You see that how easy it is to actually create your guiding curve. This is inside the mesh, so I can tweak this and make it the way it needs to be. So I have my 2 profiles now. I'm ready to move to the next step, and this is the loft command. Loft command is again in the surfacing menu. You click on the surfacing and select loft. Make sure that the edge chain is selected, because in this case it will take all the connected edges and it uses as one profile. I just click here to pick my first profile, and then I click on the other one. Now, as you see, if I create this as a solid, this is not going to do the work. So what I need to do is make sure the solid is turned off. And what we have here, which is quite useful in this case, is that we can expand the loft. Let's try to put a 2 millimeters, and you see that this is extended more than needed. And we have to make sure that it has more, because we will trim this and create a solid here. And I will press OK. So I created my loft surface here, which is good enough. And I can now show my whole mesh. I'll put this in top view and I'll show you why we created this. So what I will do, I will create a circle on the outside and circle inside, and then I will create my solid body. In order to do this trimming, I will just create a 2D sketch. You see it's aligned to the OXY plane, which is exactly what I need, but my problem is that I want to get the contour of the outer surface, which will give me more precise definition of my trimming circle here. For this purpose, I will just use what is called the outline mesh. The outline mesh will take what is visible of the mesh triangles and project them onto the sketch. I can just put this to 0 points so I can get more points and get a better presentation. I will then press create. So what I have now, I can hide this loft. I have an outline sketch, and then I can easily create my trimming curve here. I just selected the point and radius definition of a circle, and I can place this here. So again, as you see, this number is quite weird, so you can probably discuss this and read the specification, what this needs to be. And maybe here we need to make it 24.6 millimeters, so this can be manufactured. For the other trimming, I'll just show the loft. What our goal is to create a solid that it goes actually inside my main body, so we can get a good combined operation. For this reason, I will create my circle here. I'm not aiming to the boundaries, but just make it inside. I don't care at the moment of this value because it's good enough, and I'll press OK. So what I will do now is I will just take this and create an extruded surface. It's automatically created this as a solid body, but this is okay. What I will do now is we will select my loft surface and extrude it, and I will go to the trim command. And with the trim command, I'll start get rid of what I don't need. At any point when you click for something to be removed, the software automatically shows you what the result will be if you press OK. In this case, I see it says it's a multiple surfaces. So this is not what I need. I will hide the mesh, and in this case, I need to get rid of this surface, and I click on this surface to be removed. What happened is the software automatically, as you can see on the top right screen, tells me that this will form a solid body. This is a good indication when you use the trim command to check your progress and make sure that you have the expected result. So I created my blade, which is perfect and nice, and now I can move to the next step with the patterning, but maybe it's good to create a fillet here, so I don't need to create fillets on every other blades later. For this reason, I will just select this and pick the fillet command. I can just pick one edge, and because they are connected with the tangency, when I just create the fillet, it will automatically apply the fillet to all of them. Now my problem is that I don't know what this number is, because I don't have a feeling, so that's why I can just use this handle and move it and see what the fillet should be. But even more, I can turn the tolerance option now, and I can see instantly in real time how close am I to the reference mesh. And as you see, the fillet changes, and you can get as close as possible to the result. For example, here I can place 0.2 and see if it's okay, or I can make it 2.3, and see if I get any closer. Now you can speak with your customer and see if this is a right value for you, and just adjust your settings here. So I created this solid body now, which is nice and rounded, and we are ready to move to the next step. I will hide the reference mesh as I don't need it, and I will put the main body on just to see that my blade goes inside the other body so it can be combined together. And let's move to the next step. I will just select this and we'll go to the pattern. By default, it makes 2 instances. I counted these number of blades here are 7. I can type in the 7 and press preview. The software automatically will create the pattern for me. And of course, I'm happy with this and press OK. Again, I can check my progress here and I can see very quickly the results. As you can see here, we have a different deviation, but it is a pattern. It's exactly what we want. So this is my expected result. I will press close. But at the moment we have 2 bodies. One is the circular pattern of all the planes and the other one is the main one. So what I need to do is the last step. I just select everything and the software automatically offers me to combine the selected solid. You can access the combined selected solids from here, or you can click on the arrow next to the trim and press combine. The software created the combine operation, which is a solid body, and this is what I need. You're ready to export this for manufacturing and to other processes. So this was a quick tutorial where you can learn how to use the 3D sketching, the tolerancing, and the compare functionality. And I hope you enjoyed this video. Thank you for watching.